Hey there, hope you're doing good. Today I'll talk about how to avoid writing code that goes into infinite loops. Infinite loops can happen because of iteration, where the termination condition of a loop is never met, or because of recursion, but the principle is the same. The key principle is write code that always makes progress. In each iteration of the loop, you should make some progress towards the goal. So if your progress was X before the iteration, after the iteration it should be Y, where Y is greater than X. Not greater than equal to, but strictly greater than. So you should always make progress. Even a small amount of progress is enough. Let's look at this with an example. Let's say we have an e-commerce store. People are placing orders. You need to pack them into bags. Each bag has a weight limit. So if I've ordered 10 items, um, they may exceed the weight limit of one bag. So we need to split them into bags. Let's look at this Python pseudocode. I'll quickly walk you through it. Assume there's a class item that represents an item you have ordered. It has a property called weight. There's a constant called max weight per bag. And you have a function pack, which takes an array of items and returns an array of bags. And each bag contains an array of items. So if I've ordered A, B, C, D, E, bag 1 could contain A and B, bag 2 could contain C, D, and E. And the logic is simple. You start with an empty array of bags, you pack one bag. You pack one bag in the singular. If there are any items remaining, you pack one more bag, and so on. So then the question is, how does this pack one bag function work? It takes an array of items and returns a bag containing selected items, and it removes them from the argument. So if this contains A, B, C, D, E, and A and B have been selected to be put in the bag, then the return value will be A and B, and the argument will have A and B removed from them. Let's look at the logic. Start with an empty bag weight. Each time in the loop, you check if there are no items, in which case you return the bag. Maybe this function is invoked with an empty list, or it was invoked with a list of items which have all been put into a bag, so there's nothing remaining. If there is an item, you take the first item, you check whether the bag weight and the item weight together exceeds the max weight per bag. If so, you're done packing that bag. We are not talking about an optimal packing. This is not a bin packing algorithm. Any valid packing will do, right? So you add them up, and if it is greater than, so if the max weight per bag is 10 kgs, there are already 8 kgs of items in it. You can't put in a 3 kg item in it. So you return the bag. Otherwise, you can put the item into the bag. So you do so. You remove it from the input and you add the bag weight to the item weight because you put one more item into the bag. This algorithm looks correct. But there is a situation in which it can go into an infinite loop, which is that one of the items is heavier than the max weight per bag. Imagine someone ordered a very heavy item like a refrigerator. Now, this shouldn't actually happen because that order shouldn't have been accepted if it can't be delivered. Or maybe there's a separate flow for heavy items. But whatever it may be, you should write code defensively, defensive programming. Don't just design for the ideal case. So here you would say and bag dot bag weight greater than 0 then only you return the bag. So the change we are making is if the bag has no items at all, right? Imagine this is invoked with only one item which is extra heavy. So the max weight per bag is 10 kgs, this item is 20 kgs. To declare that the bag is full, the bag must have something in it. You can say bag weight greater than 0 or you can say bag dot size greater than 0, either way. So what are you doing here? You're saying that if the bag is empty, then even if the item is super heavy, we are still going to put it into the bag. This code will not go into an infinite loop, right? Whereas the earlier one would. Why would it go into an infinite loop? Pack one bag would get invoked. It would return an empty bag. And then it would invoke again and again and again. And since nothing is being put in the bag, nothing is being removed from the argument. So it will always be non-empty. So the loop never ends. So with this change, with this AND condition, this code always makes progress on every iteration. Every time pack one bag is invoked, unless it is invoked with an empty list, which is this case, it will take the first item and put it into a bag. It may put in more items or not into the bag, but at least one item has been put in the bag and removed from the input. So it has made some progress. So make some progress on every iteration. Now you may think this is an edge case. Like, why would I do this? This is weird. This is made up. But then no one writes code that goes into infinite loops on purpose. It happens exactly because of unforeseen scenarios. To prevent those, write code that makes some progress on every item. And if you're thinking, isn't putting a over heavy item into a bag an error in this modified code? It should have been caught at some other layer in the system. For example, you shouldn't be allowed to list a very heavy item like a locomotive on Amazon. And if that was allowed, it should be caught elsewhere. But in any case, going into an infinite loop is not the right way to deal with invalid input. You can throw an exception, for example, saying too heavy item form. That's also valid. But even this is fine because it is not the job of this algorithm to detect heavy items. It is just to pack them. And it is doing that without going into an infinite loop. So with this modified code, even if the even if one of the items is too heavy, higher than the max weight per bag, it makes progress. So always keep this in mind. Make progress on every iteration. If you found this useful and you would like me to guide your engineering team, my consulting link is in the description.